All right, guys, we are halfway there. We are going to start our next section, which is going over the National Electric Code. This book is our pride and joy, or maybe it's not. Maybe you have absolutely no idea how to navigate this book. Maybe you have barely seen it one or two times in your career. Maybe you're brand new, or maybe you know it in and out. Maybe you teach on the NEC. Either way, it's going to be good for us to go back to the beginning. We're going to start again with the origins, that go over the committee personnel, the introduction, chapter 1, chapter 2, 3, 4, 5, 6, 7, 8, 9, and then the informative annexes. And as promised, I have a little something special. I'm going to take you guys into a building that we just finished and apply some of the codes in there and kind of walk through how we did an entire lighting retrofit in a building. I want to explain the lighting control system that we used. I want to explain the parts and pieces, how it works, and help you guys out just to kind of see. I'm sure some of you guys, I know that these products are being used all throughout many different states. You know, we got different lighting control systems like Enlight, Lutron, Crestron, Green Gate. Then you got your ETC, your DMX, the color changing lights. You got so many different types of lighting control systems. And that's really where I have focused for the past 5-6 years of my career. So I want to kind of help you guys out with some good lighting knowledge, lighting installation knowledge. We'll go over some motion sensor stuff, but we're going to start with the code book, and I want to give you an overview, excuse me, of that, and then we'll kind of move into the lighting, and we'll kind of integrate the NEC into it. So without further ado, here we go. NFPA, excuse me, NFPA 70, also known as the NEC, the National Electric Code. This code is adopted in almost all 50 states. It is not a federal document. It is not mandatory for every single state, city, municipality, county. Some use it, some don't. Some use portions of it, some don't. So this was created by the National Fire Protection Association, as we'll see. The origins of this book, that this edition of NFPA 70, the National Electric Code, was prepared by the National Electric Code Committee and acted on by NFPA at its June Association technical meeting held June 17th through 20th, 2019 in San Antonio, Texas. It was issued by the Standards Council on August 5th, 2019, with an effective date of August 25th, 2019, and supersedes all previous editions. Again, we know that the code has been here for a long time. We'll see that when we get into the history and development. This code was issued with tentative interim amendments that impacted provisions in 210.52, 240.67, 240.87, 725, 121, and Annex D3. Subsequent TIAs on 356.10, 551.71, 800, 100, 225.30, 716, and Table 16 have been issued and incorporated into the code. For more information, you can go see their website and check that out. This edition of the NFPA 70 was approved. This is the 2020 code as an American national standard on August 25th, 2019. But remember, not everybody adopts it. Some states are years behind the 2020. Some states are really close. Some states are on the 2017 right now. Some states are in the process of adopting the 2020. So it's really up to the governing agency, whether that, again, that's the city, the county, the state, to say, yes, we want to adopt this as our standard across the board. History and development of the National Electric Code. The National Fire Protection Association, the NFPA, has acted as sponsor of the National Electric Code since 1911. The original code document was developed in 1897 as a result of the united efforts of various insurance, electrical, architectural, and allied interests. I remember I got to see a really early version of the code. Our training center was getting rid of a whole bunch of books, and our training center has been around for a long time. And I forget what year it was, but it was a really early edition, and it was about this thick, super small, only like this big. And it was, you could just tell, it was pretty cool to see such an old, and to see where we have come from then as electricians. In accordance with the regulations governing the development of NFPA standards, a National Electric Code first draft report containing the proposed amendments to the 2017 National Electric Code was published by NFPA in July 2019. Again, this book is almost exactly the same in as far as we're discussing how it comes about and how the edits are made, how the committees oversee that, and then public comments are allowed to be inputted, and then they make the final revisions before their final publishing of the actual code. This report recorded the actions of the various code-making panels and the correlating committee of the National Electric Code Committee on each public input and first revision that had been made to revise the 2017 code. The report was published at nfpa.org following the close of the public comment period. That's what we were talking about. The code-making panels met, acted on each comment, and created some second revisions, which were reported to the correlating committee. NFPA published the National Electric Code second draft report in April of 2019, which recorded the actions of the code-making panels and the correlating committee on each public comment on the National Electric Code Committee's first draft report. The National Electric Code's first draft report and the National Electric Code second draft report were presented to the 2019 June Association technical meeting for adoption. So again, that's how it works. Each committee is over their specific section of the code. Public comments come in, they look at it, and they make revisions if they deem them necessary. You can see here, this is the 55th edition. First printed edition was in 1897. That might be one of the attendance verification questions on the next, as soon as we finish this video. 1897. That might be important to remember. This code is purely advisory as far as NFPA is concerned. It is made available for a wide variety of both public and private uses in the interest of life and property protection. These include both use in law and for regulatory purposes, and use in private self-regulation and standardization activities such as insurance underwriting, building and facilities construction and management, and product testing and certification. Committee personnel. We're not going to read all these, but again, here's the breakdown. Here's the chair, Michael J. Johnston. You might even see some people you know in here, depending on who you work for. It's a lot of different people. You can become a member to be on one of these committees. You see here, this guy's in IBEW. We got IEC here, American Chemistry Council, Schneider Electric, Electric Light and Power Group. There's tons of them, tons of people, and they oversee all the different sections. This is much bigger because the code, the NEC, NFPA 70, I keep saying that so that you remember, NFPA 70 is the NEC. NFPA 70E is electrical safety in the workplace, okay? NFPA 70 is the NEC. Got it? That might be important to remember too. Maybe that'll be our second question. voting alternatives. So some of these are voting members, some of them are non-voting members. AES Engineering, the chair for the code making panel number 2. You can see it here. This is the second code making panel. This is what they're in charge of. Articles 210, 220, Annex D, examples D1 through D6. That is what this group of people are in charge of. The next section, code making panel number 3. They're in charge of these sections. Does that make sense? You guys following me on that? The chairs, IEC. Let's see some companies out here. Automatic Fire Alarm Association, NEMA's on here, Cisco, ABC right here, Associated Builders and Contractors. He's a representative from them. IAEI, the International Association of Electrical Inspectors. If you guys have never heard of them, they actually come out with a book that is all of the code changes, every single one of them. Every time there is a code cycle change, they come out with a new book. And that book is absolutely fantastic. It has every single change in the National Electric Code for that code cycle. I have the one for the 2020 edition. It's fantastic. I would encourage you guys, pick that up. People in the electrical industry, if you want to learn those things, you can get that book. Travelers Insurance Company, CME Consulting, alternates. These are alternates in case these people are not available, and so on. You guys can see that code making panel 4, 5, 6, 7, 8, all of that, all those guys. Introduction, Article 90. Again, we talked about this over in NFPA 70. E, it's the same thing. It's going to look really close. There's some extra stuff on this. I actually wrote an article on this and made it free to everybody so that they could read this. This is a very important. This is why the code is here. This gives us the exact reason why it exists, what it covers, what it doesn't cover. We'll go through a couple of these. We're not going to go through the entire thing, but 90.1 purpose right here. Practical safeguarding. The purpose of this code is the practical safeguarding of persons and property from hazards arising from the use of electricity. Sounds very familiar to the other one. This code is not intended as a design specification or an instruction manual for untrained persons. 99% of the stuff that is in this code book, if you were not an electrician, it would be very difficult for you to understand. You might understand the words, the grammar, things like that, but the actual application of the particular code reference that you're looking at, you're going to really struggle to understand it. Really, my understanding of the code has grown as my experience in the trade has grown. Does that make sense? Because the more we're exposed to, obviously, the more times we go to the code book, the more things that we're exposed to and experience we're able to actually apply when we go into this book. So when I was a first year, I had no idea what was going on. Now being 13 years into the trade, having had to deal with swimming pools and swim up bars in casino pools and low voltage that was designed to be over a pool. And I mean, there's so many things that happen throughout our careers that cause us to increase in our knowledge in the code book. I say that so that you guys don't feel like you're miles behind. I have tons to learn still in the code book. I haven't experienced even a quarter of all of the stuff that's in here. And each and every one of us probably has different experiences with different areas of the code book, right? Residential guys, commercial guys, industrial guys, linemen, whoever it is, maintenance electricians, service electricians, you know, we all have different experiences. And so we're going to see the code from a different light. But this Article 90 is very important for all of us, no matter what areas of the code we specify in more. So adequacy. This code contains provisions that are considered necessary for safety. Compliance therewith and proper maintenance result in an installation that is essentially free from hazard, but not necessarily efficient, convenient, or adequate for good service or future expansion of electricity. Okay. C, relation to other international standards. The requirements in this code address the fundamental principles of protection for safety contained in section 131 of International Electrotechnical Commission Standards 364-1 electrical installations of buildings. 90.2 covered. We're going to see what's covered and what's not covered. Right here, well, let's get there. This code covers the installation and removal of electrical conductors, equipment, and raceways, signaling and communications conductors, equipment, and raceways, and optical fiber cables for the following. Number one, public and private premises, including building structures, mobile homes, recreational vehicles, and floating buildings. Again, this is a list of what is covered. Number two, yard lots, parking lots, carnivals, and industrial substations. Number three, installation of conductors and equipment that connect to the supply of electricity. Number four, installations used by the electric utilities, such as office buildings, warehouses, garages, machine shops, and recreational buildings that are not an integral part of the generating plant, substation, or control center. Number five, installation supplying shore power to ships and watercraft in marinas and boatyards, including monitoring of leakage current. And number six, installations used to export electric power from vehicles to premises wire or for bidirectional current flow. These are all things that are covered in this code. Now, you can probably barely see it. You're going to have to zoom up maybe, but you can notice that these two, number 5 and number 6, are highlighted. There's a pink background there. What that is showing us in this particular code is that those are changes from the 2017 code to the 2020 code. These two sections were not there before, and they are there now. This is imperative. If you have a hard copy, they usually put a gray highlight around these sections if they were changes. Here online, they put a pink background. Excuse me, my voice is going out. So that's important for you guys to understand. And then right here, this is fantastic on the online version of the code. They have this enhanced content that helps us to understand these sections even more. This is absolutely fantastic to have. I mean, illustrations in here. It's great. I mean, you can buy the illustrated guide to the NEC, but to have this online on your phone, it's just fantastic. B, not covered. This code does not cover the following: installations in ships, watercraft, other than floating buildings, railway, rolling stock, aircraft, or automotive vehicles other than mobile homes and recreational vehicles. Does this look familiar? It's basically the same thing as over there in NFPA 70E. Number 2, installations underground in mines and self-propelled mobile surface mining machinery and its attendant electrical trailing cable. We're not going to go through all these. We already read these in the other one. One thing that I do want to point out is that although these are not covered by the NEC, that does not mean that these installations are not covered by another type of regulatory code, right? The railroad, the utility companies, they all have different codes. So just because it's not covered in the NEC does not necessarily mean that it has no governing agency telling the installers how to install in those type of situations. I just really wanted to point that out because a lot of people think that the NEC covers everything, anything electrical, automobiles, all this stuff. It doesn't, but they have their own code that they have to follow through different governing agencies. A special permission The authority having jurisdiction for enforcing this code may grant exception for the installation of conductors and equipment that are not under the exclusive control of the electric utilities and are used to connect the electric utility supply system to the service conductors of the premises served, provided such installations are outside a building or structure or terminate inside at a readily accessible location nearest the point of entrance of service conductors. So this section is telling us that the AHJ has the ability to allow an installation to not follow the code if they deem that it is a safe installation. They have a lot of power. That's a special permission that can only be granted by an authority having jurisdiction. It's typically not something that we come across. We usually just go by the code. The inspectors know the code. I've never seen a special permission myself. Perhaps some of you guys have, maybe the guys who've been here in the trade longer, maybe you guys have seen it, but I have not. 90.3, this is important. This is our code arrangement. This gives us a visual understanding of how this code is broken out. This code is divided into the introduction and 9 chapters, as shown in figure 90.3 below. Chapters 1, 2, 3, and 4 apply generally. Remember, we heard that term in NFPA 70E as well. 1, 2, 3, and 4 apply generally to all installations. Chapters 5, 6, and 7 apply to special occupancies, special equipment, or other special conditions and may supplement or modify the requirements in chapters 1 through 7. So let's look at a visual. Chapter 8 covers communications and is not subject to the requirements of chapter 1. That is the one chapter, like it says here, that is kind of its own lone wolf, if you will. It has its own requirements, and it has to do with communication systems, except where the requirements are specifically referenced in chapter 8. So some of the code sections might be referenced in chapter 8 that are in other sections, and then it does apply to communication systems. Chapter 9, tables that are applicable as referenced, and informative annexes are not part of the requirements of this code, but are included for informational purposes only. Remember, informational annexes and informational notes, which we'll see again down below, are there for helping us to understand the code more. Here's the picture that we're looking at. Chapter 1, general. Chapter 2, wiring and protection. Chapter 3, wiring methods and materials. Chapter 4, equipment for general use. Chapter 5, special occupancies. Chapter 6, special equipment. Chapter 7, special conditions. And Chapter 8, communication systems. Chapter 9, tables. And then we have our informative annex A through informative annex J. Again, chapters 1 through 4 apply generally to all electrical installations. Chapters 5, 6, and 7 supplement or modify chapters 1 through 7. Chapter 8, communication systems. Chapter 9, tables. And your informative annex A through informative annex J. 90.4, enforcement. This code is intended to be suitable for mandatory application by governmental bodies that exercise legal jurisdiction over electrical installations, including signaling and communication systems, and for use by insurance inspectors. The AHJ, or authority having jurisdiction for enforcement of the code, has the responsibility for making interpretations of the rules, for deciding on the approval of equipment and materials, and for granting the special permission contemplated in a number of the rules. By special permission, the authority having jurisdiction may waive specific requirements in this code or permit alternative methods where it is assured that equivalent objectives can be achieved by establishing and maintaining effective safety. Again, the AHJ has the power to do that, but Their goal, again, is to establish and maintain effective safety. This code may require new products, constructions, or materials that may not yet be available at the time the code is adopted. In such event, the authority having jurisdiction may permit the use of the products, constructions, or materials that comply with the most recent previous edition of this code adopted by the jurisdiction. 90.5, mandatory rules, permissive rules, and explanatory material. A, mandatory rules. Mandatory rules of this code are those that identify actions that are specifically required or prohibited and are characterized by the use of the terms shall or shall not. We went over that in the last one. If they use those words, it's mandatory. Permissive rules. Permissive rules of this code are those that identify actions that are allowed but not required, are normally used to describe options or alternative methods, and are characterized by the use of the terms shall be permitted or shall not be required. C, explanatory. This is just talking about explanatory material, informational notes and annexes that are there for our informational information only. Informative annexes. Non-mandatory information relative to the use of the NSC is provided in informative annexes. Informative annexes are not part of the enforceable requirements of the NEC, but are included, again, for informational purposes only. And then we have, again, formal interpretations. You can go through that process. You don't understand something, and you can send it in and ask for a specific interpretation directly from the committee so that you know exactly what that standard is saying. Again, we see here the pink. That lets us know that there was a change made from the 2017 to the 2019. Examination for equipment, for safety, wiring planning, number of circuits and enclosures, units of measurement, dual systems of unit. There's a lot of other stuff in here. Permitted uses of soft conversion, compliance, and that is the end of section 90 or article 90. Let's go into the next section. Introduction. We're not going to read, chapter 1, general. In here we see we have our definitions. We have article 110, requirements for electrical installations. And we have chapter 2 is wiring and protection. Chapter 3, wiring methods and materials. Chapter 4, equipment for general use. Chapter 5, special occupancies. Chapter 6, special equipment. Chapter 7, special conditions. 8, communication systems. 9, tables. Let's just look at one of these real quick. Article 100, definitions. We know what's in there. You guys need to find a definition about something. This is where you need to come. You need help interpreting one of the code references. You don't understand what something means. Come to the definitions, you find your answer. Article 110, requirements for electrical installations. This article covers general requirements for the examination and approval, installation and use, access to, and spaces about electrical conductors and equipment. Enclosures intended for personnel entry and tunnel installations. Approval. The conductors and equipment required or permitted by this code shall be acceptable only if approved. 110.3, examination, identification, installation, use, and listing. You haven't heard of listing. UL listing is anytime a product is created, it has to undergo testing by different testing laboratories. A lot of people think that UL is the only listing agency. There are many different listing agencies. UL just happens to be one that is very widely known and used a lot. Installation and use. Listing right here. Voltages. Throughout this code, the voltage considered shall be that at which the circuit operates. The voltage rating of electrical equipment shall not be less than the nominal voltage of a circuit to which it is connected. 110.5, conductors. Conductors used to carry current shall be of copper, aluminum, or copper-clad aluminum unless otherwise provided in this code. Where the conductor material is not specified, the sizes given in this code shall apply to copper conductors. Where other materials are used, the size shall be changed accordingly. Conductor sizes. Conductor sizes are expressed in American wire gauge, AWG. I like to say AUG. You can say it however you like, or in circular mills. You got your 12 gauge, 10 gauge, 8 gauge, all the way down, and then you got them going up. 22 gauge, we got our 0 to 10 wires that are typically somewhere between a 16 and a 22 gauge for our 0 to 10 volt dimming, things like that. AWG, or circular mills. 110.7, wiring integrity. 110.8, wiring methods. 110.9, interrupting rating. 110.10, circuit impedance, short circuit, current ratings, and other characteristics. The overcurrent protective devices, the total impedance, the equipment short circuit current ratings, and other characteristics of the circuit to be protected shall be selected and coordinated to permit the circuit protective devices used to clear a fault to do so without extensive damage to the electrical equipment of the circuit. This fault shall be assumed to be either between two or more of the circuit conductors or between any circuit conductor and the equipment grounding conductor permitted in 250.118. There's a whole lot more in this article. We could keep reading. One thing that I want to point out for those of you who might be working toward becoming a journeyman, becoming a master electrician, there are a lot of different resources for you to take your test. You can, I found, search online. I think there's electricianpracticetest.com. They have, I think there's 25 different tests on there. And all it is you go on and it's question after question after question after question. So if you're in that point in your career where you're looking to move and get that new license, look for that. That's a free resource. They do sell a lot of training courses where you can go on there and they'll help walk you through. And some of those are good. I like to try and find the free stuff myself. And I found that if you just answer question after question after question after question, use the table of contents, use your index, use all of those things in the code. And the more questions you answer, the better you're going to get and the faster you will get. And the more coverage you will get throughout the code book. So that's how I ended up passing my test. Just question after question after question after question. Look in the index, see how things are situated. Sometimes you'll find an answer in the table of contents, but you can't find it in the index. You look in the index and you can't find that answer in the table of contents. So you kind of have to jump all over the place, but just take a bunch of questions and answer them over and over and over and over again, so that you can take a step to that next level. All right, I want to move on from this and bring you guys to the lighting, my favorite aspect of the electrical industry. I like the instant gratification that comes. I know right away whether something works or not. It's the same with receptacles. You can put a plug tester in there, but the fact that the lights come on, I mean, we're working with some pretty intricate systems where we have fixtures that face down and up, direct, indirect light fixtures. We have power packs, we have motion sensors, daylight sensors, we have all of this different stuff. Wireless communication, wired communication, wireless communication, where you have these switches that you have to wire into line voltage, but then the communication is a wireless Bluetooth communication or a wireless radio frequency communication. It's very intricate. It has been very satisfying, and it really never lets down because the technology is constantly evolving, constantly changing. And for those of you who have had experience in the lighting world, installing these systems, it is, I love it. I turn the lights on, I see lights out, I have to go troubleshoot, my brain's spinning. It's making me super mad, but then when I finally am able to figure it out, you know, that satisfaction comes in. So perhaps you love single line, perhaps you love um, rope and walls, perhaps you love the whole hog. Perhaps, I don't know what your particular little niche is within the electrical industry that you like, but I mean, everybody has theirs. And for me, it's lighting. And so I think that you guys can gain some good information from me going over this stuff. So I want to take you guys right here. So this building is a 2-story, 20,000 square foot facility. It is in the pharmaceutical industry. They do science experiments. They work on mice. They're creating different medicines, vaccines, different things like that. They came to us asking if we would go into their building and we would completely retrofit the lighting. So we have an active facility. People are already there working. We had to create zones throughout the building, give them dates that we were going to be in those zones, and make sure that we hit that schedule that we created. So to start, you can see this is, let's go back up to, these are the approved building plans right here for a building here in California. This is the building Gilead. We are looking at breakdown here. This gives us our lighting layout. It is just a preliminary drawing. We had to do some edits on this, change the fixtures out, actually go in. The first step for us, for me, actually was to go walk this building. We had a set of as-builts that was provided to us, and from a previous contractor who did the initial installation. And we went in and I had to walk every single light fixture and verify that the light fixtures that were shown on the prints had not been changed over the years. Back in 2015 is when they did the transformation here. The remodel. They did a remodel in this building, and that happened in 2015. So we needed to go in and verify that they actually installed what they said that they were going to install. So I walked the building, put check marks on every single fixture. If a fixture had been removed, I removed it from the prints so that we didn't pay for an extra fixture that we did not need to be there. Then we got to the next step. Once we had our counts, I had to deal with our project manager and figure out what lighting control system they wanted. This particular building has about 8 different buildings, and they had a specific lighting control system in there, and they they wanted to match. So they wanted us to use the same lighting control system. So that's what we did. I then had to figure out, now that we had the lighting control system set, what type of lighting controls were we going to use, because this particular manufacturer has varying options. So you have the wired, and like wired is what it's called, where you have to run Cat5 cables for communication all throughout a building, or they had the wireless communication. So we had to try and figure out what we were going to do, what was going to be the best application, the least invasive and the most cost efficient for us, while at the same time still providing them with the energy savings that they were looking for. That was the whole reason for doing this. They had fluorescent fixtures in there all throughout the building. They wanted to get rid of those fluorescent fixtures. We ended up providing them with about a 65% reduction in overall electrical cost. So their kilowatts per hour went down substantially. This building is now done. I'm in the preliminary stages, actually about to start the job come up next week. So I had to go through the same phases, learn some things from doing this first project, changed a couple things around. But let's go into the wiring diagram. I want you guys to see this. So you get into this system here, and this is a breakdown. So this is going to show us the components of this lighting control system. They're all different. They're all pretty good. Some of them are better than others. This one is pretty good. Some of them have more installation costs to it because you have more wires you have to deal with. So they just differ. It's really up to personal preference for the owners, what they want. And like I said, for this one, they went ahead and went with Enlight. So you can see here, the way this system is set up is it has what we call a main brain. It is a main brain for the entire system that houses all of the programming, okay? So I want this light to turn on at this time. I program it in that, what they call an eclipse. It keeps the programming, just got a little computer in it. It knows what it's doing. You tell it what to do with a specific program, and it does it. The way that this system is set up is the communication in this picture is all Cat5 communication. So what I want you guys to think about when we're talking about Cat5 communication, okay, you need to differentiate in your mind the communication side from the power side, okay? You have the power side, which is our line voltage. That's what we call it. For those of you who don't know what that means, that is our power coming from the panel. Sometimes you have 120 volt lighting. Sometimes you have 277 volt lighting. In other countries, they use different voltages. But here in the United States, it's typically 120 or 277 for your lighting. The control system, and anytime that I am explaining Cat5 or communication, that is completely separate from the line voltage. You still have to have line voltage. We are not providing power to the fixtures to turn them on from the Cat5 low voltage. We cannot do that. The efficiency is not quite there yet. There are some PoE systems, which is called power over Ethernet, where they're actually now powering light fixtures from an Ethernet cable, a Cat5 cable. It's pretty crazy. Think real quick. What do you think some of the issues are with Cat5 and trying to provide power to the fixtures? Think about it for a second. Well, the number one thing is efficiency, right? So when we talk about power or amperage current going to a fixture, we know that we can only push so many amps over a wire that's this big. So you have Cat5 wires that are super small. I don't know what the gauge of them is, but they're very small. And you're trying to push, I mean, even though these LEDs are pretty efficient fixtures, they're still not that efficient to where we can push, you know, half an amp, a full amp, 2 amps through these Cat5 cables yet on a massive scale, right? So a lot of our lighting control, you see our circuits, we have tons of light fixtures on a 277 volt circuit. Well, we're just not there yet. As the efficiency gets better, as we're able to provide the same amount of light with less amps, we'll start to see these new systems, these PoE, we'll see them start evolving as we reduce our energy consumption. But for now, what I want you guys to do in your brain is to differentiate. You got your power side and you have your low voltage communication side. I'm going to use terms that are going to kind of bring the two together for you. And also, we want to make sure that we're not forgetting that we are talking about the NEC here. So we want to talk about how strapping of MC, supporting of boxes, different applications. You guys be thinking about that as we're going through. I really want you guys to learn from this. So think about these things. You know, hey, look here. This is an as-built. So I want let's start here real quick. So you got your main brain right here. Then you have what's called a bridge. Okay, this bridge is, think of it as a branch panel. Just think of it as an electrical panel. But remember, differentiate communication from your power side. Okay, this is like a branch panel. Each one of these ports that you see right here coming out, that's like a switch leg that's coming out. So you're bringing a switch leg out of that bridge to a specific group of lights. So let's take, for instance, one little office. Let's find an easy one. Maybe this one. Let's go to a different sheet here. Be easier for you guys to see here. No. Right here. So in this room, this is what we would consider one control zone. So this is one office. Here's the door. Everything's kind of hiding it right now, but here's the door. They walk in, they have two fixtures. There's maybe a desk back here on the back wall, and they come and they sit in their chair. And these are the two fixtures and one switch on the wall right here, and a motion sensor and a power pack. This square box is a power pack, or it's a relay. It's basically a switch. And then you have your, what we call low voltage switch. This is one control zone. So I'm going to bring a home run from my bridge, and I'm going to land that in this power pack. And then I'm going to jump from this power pack to this motion sensor. And then from this motion sensor, I'm going to go to my switch. And then I'm going to stop, because that is my switch leg. And by taking my Cat 5, I've already brought, remember, power communication. I've already brought my line voltage here. I've brought my line voltage into my power pack. I've broken it, just like a switch. It's a relay. And I tied the hot side into the line side of the relay, and I tied the switch leg to the load side of the relay, and it went out to my light fixtures. That's this right here, this wire, and then it jumps over here. So this is now my actual switch. But how do I tell it what to do? How does it know when to turn the lights on? Well, that's where the Cat 5 comes in. I run from my bridge and I land into my power pack. And then I come out of my power pack and I land in my motion. And then I come out of my motion and I go into my power, or my switch, my low voltage switch. So what happens here is when I do the programming for this office, I am going to tell this power pack to listen to this motion sensor and to listen to this low voltage switch. So guess what happens? When I come in the room, if this motion sensor is turned on, if I have programmed it and it's all set up, I'm going to walk in this room. This motion sensor is going to detect my motion. And it is then going to tell this power pack to close the relay and allow the power, again, power side communication. We're talking about the power from the 277 volt panel now. Allow that power to flow through this power pack, out this wire, into this fixture, and then into this fixture. Lights come on. Now, what happens if I come over here to the wall and I press the switch to turn it off? Well, I'm overriding the motion sensor now, and I am now telling the power pack that it needs to open. Relay open, no voltage going through. Relay closed. Think of your fingers like this. If it's open, there's no power going through it. If your fingers are closed, power can flow through there. That's what's going on here. In simplest terms, that's how this entire system works. It can get really intricate. You can start setting up points lists where they can have a building management system and they can view every one of the rooms. They can see if somebody's in that room or not. This particular building, they actually did that. They wanted us to set that whole system up so that in one of their buildings, they can monitor and they can see when someone's in their room and when someone's not in the room. And this isn't surveillance. There's no cameras that are watching in these specific rooms. What it's doing is giving them the ability to see the rooms that have a higher usage and to see if there's some way that they can reduce the amount of energy in that space. So let's say you had a room where there's a whole lot of people all the time, a break room, a bathroom, something like that. And there's high foot traffic in those areas. They might want to reduce the lumen output in those rooms because they know that they're going to be on for a longer period of time. Plus, it's a break room. You don't need the lights to be at 100%. So they'll dim them down in the programming so that when someone comes into the room, instead of the light fixture coming on, let's say at 100%, it only comes on at 70. And really, to the naked eye, 100 to 70 is pretty substantial. You'll be able to see it. But if you go from 70 to 60, a 10% drop, you're not really going to see it visually. So that's something to keep in mind as far as energy savings for those of you who are installing lighting control systems, whatever the product may be. You can, and also for you employers out there, you can sell energy efficiency. It's big. People want to save money. They don't want to spend tons of money on their electricity. And so if you can bring them a service that hey, I'm going to save you an overall savings of 40% on your lighting load, which tends to be the biggest load in buildings, depending on what type of occupancy it is. If you can provide that service to them, that's fantastic. And people love that, especially the bigger buildings. They're really looking for this right now. And if you can provide that, and then also if you understand these systems, you apprentices and journeymen, and I mean even foremen and master and wherever you are, you need to understand this because these systems are only coming more into the market more and more. And you'll give yourself a leg up in the industry by far if you can understand these systems. And a lot of these different manufacturers, they have free training programs that you can go on. So if you are installing one of these systems, I know Enlight is in the Dallas area. I think they're in Austin as well. I don't know if you guys are in that area working on those buildings, but they have all of this stuff going on. And it's really good to learn these systems. And then also keep in mind, when we're roping the MC, we have to make sure that we're strapping it, right? That we're putting the bat wings on, that we're installing the J boxes appropriately, that we're using ground tails in our boxes per the NEC, that we're making sure that we're tying off our light fixtures and we're screwing them off if that's required. Every single one of our lighting installations needs to be like that. So we're coming to the end of the third video, and we're going to move on to the next one. So we will see you guys here in a minute.